Okay, so this is a question that is part of your lab tests. Okay, I just want to explain how you get the answer in case it comes in your exam or something. So a sample of impure magnesium was analyzed by allowing it to react with excess hydrochloric solution. So after 1.32 grams of the impure metal was treated with 100 cubic centimeters of 0.750 mole per decimeter cubed of hydrochloric acid, the remaining solution required 50 cubic centimeters of sodium hydroxide for complete neutralization. Assuming the impurities do not react with the acid, what is the percentage by mass of magnesium in the sample? What an interesting question. I love it. Okay, so we've been given the mass of the impure metal, that is, and then we are getting to react it with hydrochloric acid that is in excess. So this is back titration. That is all you get to do. So how do we get to handle such a question? So we are reacting this impure metal of 1.32 grams with 100 cubic centimeters of 0.750 of hydrochloric acid. So what is the first reaction? So while this metal reacting with HCl in the first reaction. So assume this metal will form, of course this metal what we're dealing with is magnesium. Is this, yeah, magnesium. So magnesium, so that we have magnesium chloride there, of which we know they are in the ratio of 1 to 2. So magnesium chloride, what other product do we expect to have? So hydrogen, I believe so. Okay, so what is our reaction? Now, what information are we given about the hydrochloric acid? We've been given the volume as well as the concentration. But we believe that back titration we start from the second reaction. So now in the second reaction, the interesting part was the remaining solution required 50 cubic centimeters of sodium hydroxide. So the excess one was the hydrochloric acid. So it gets to react in the second reaction with sodium hydroxide. Of course, we have sodium chloride plus water. That's the interesting part. Now, quickly, what information have we been given in the second reaction? We've been given that it was 50 cubic centimeters of sodium hydroxide of 0.250 mole per decimeter cubed. So that was the concentration and the volume respectively. So if we have that information, we need to get the information of the HCl that was in excess. Now we do basically understand that these guys are in the ratio of 1 to 1. Therefore, same number of moles required for complete neutralization. So if we can get the number of moles of sodium hydroxide, we should be able to get the number of moles of what? Of hydrochloric acid. Okay, so let's get to do that. So we do understand that we need to make sure the units are matching in our calculations. So therefore, if we are working with decimeter cubed, we need to convert the 50 cubic centimeters to that. And we know that 1 decimeter cubed or 1 liter is equal to 1,000. Alright? 1,000 cubic centimeters. So just perform a simple calculation there and divide your 50 by 1,000. So 50 divided by 1,000, I'm getting 0.05. So 0.05 decimeter cubed. Now at this point we're able to find the number of moles. We know that the number of moles is the product of concentration and volume. Okay, so 0.250 mole per decimeter cubed multiplied by 0.05 decimeter cubed. So that is going to the decimeter cubed going to cancel out. So at ultimately you get to remain with the number of moles. Okay. So the number of moles that I'm getting, the answer is 0.0125 moles. Now we know that the HCl and the hydrochloric acid are in the ratio of 1 to 1. So that is your answer there for the number of moles. So we have a number of moles of hydrochloric acid that were in excess because we believe in the second reaction what was reacting is what was left over from the first reaction. So these are the number of moles that were in excess. Okay. Now, what other piece of information were we given about hydrochloric acid? So we were told hydrochloric acid was of a concentration of 0.750. So we have its concentration to be 0.750 mole per decimeter cubed. So we should be able to find, using the two information, we should be able to find what? The volume. So we know that concentration is equal to number of moles divided by the volume, right? So for us to get to find the volume, we'd have to divide the number of moles by the concentration. So number of moles by the concentration. So volume, number of moles by the concentration. Concentration was 0.750 mole per decimeter cubed. So therefore our volume 0.0125 divided by 0.750. I'm getting 0.016667 decimeter cubed. Okay. So we can decide to convert this decimeter cubed to cubic centimeters by multiplying by 1,000. And as we get to multiply that by 1,000, 1, 2, 3. So it will be 16.6. So 16.67 decimeter cubed. Remember, what we are saying is we're just trying to determine the volume using the concentration and the number of moles that were in excess. So therefore, the volume that we've calculated is the volume that was what? That was in excess. So if we are to subtract this answer from the initial volume of the HCl, which was 100, we are going to get what? We are going to get 83 as the initial volume. Sorry, this is supposed to be in cubic centimeters because we've already converted. So cubic centimeters, sorry, not decimeter cubed. So this is basically representing the initial amount of hydrochloric acid that had reacted in the first reaction. Since this one is the excess coming from a second reaction by using the mole ratios with sodium hydroxide and whatnot. So we now have the initial volume that had reacted in the first reaction. Now, since we have a volume that had reacted in the first reaction, that's why we call it back titration. We've used the second reaction to get to the bottom, to the top part, so that we basically get to find how many moles of hydrochloric acid were taking part in the reaction. Now we've found the volume. We can just basically convert the cubic centimeters to decimeter cubed quickly by just dividing by 1,000. So the answer is 0.0833. Okay, so that's what we have. What units are we using? We've gone to decimeter cubed. Okay, so if we have our volume that was available initially, and then we also have our concentration there to be 0.750 mole per decimeter cubed, we should be able to find what? The number of moles. So multiply that. So 0.0625 are the number of moles of our hydrochloric acid that had reacted in the first reaction. So if we have a number of moles of hydrochloric acid, and then we are able to see that they are in the ratio of 1 to 2, it implies that every mole of magnesium, there are 2 moles of hydrochloric acid. So we just can divide this by 2. So dividing by 2 for our magnesium, we have 0.03125 as our number of moles. You can also use the ratios. Say if one gives us 2, how about 0.625? It is basically just going to take it the same thing where you get to divide by a 2. Okay, so we found the number of moles of magnesium. We can now use its molar mass. So if you got your periodic table, what's the molar mass of magnesium? Is it 24? Should be 24. Something like that. Roughly 24. So if we have our molar mass to be 24 grams per cubic centimeters, or grams per mole, sorry. We can now find the mass. How can you find the mass? The mass is the product of number of moles. So 0.03125 times 24 grams per mole. So of course the units are cancelling out because there we have moles on top. So moles and moles will cancel. So 24 multiplied by 0.03125. So the mass that I'm getting of our magnesium that had taken part in the reaction was 0.75 grams. So that represents the pure part of magnesium that had taken part in the reaction. The rest represents the impure part. Now what is the question saying? Assuming the impurities do not react, what is the percentage of mass of magnesium in the sample? So this is the true mass of magnesium. So 0.75 grams divided by 1.32 grams times 100. So 0.75 divided by 1.32 times 100. So the answer is 56.8% love-free as our solution. So that's how you get to approach this question. It's just a matter of you understanding back titration and then understanding that what takes part in the reaction is the pure part of the metal. Okay. So thank you very much for watching. Make sure you share the link with your friends so that they also get to understand as you prepare for your exams.